Okay, good afternoon. Happy Friday. I'm glad you all made it out to the final day of the conference. I'm sure some people were left behind in the journey. Welcome to a chat about something that you probably have barely heard about at this conference so far, which is AI. I do realize it's a little bit hyped. Well, we're going to try and stay away from most of the hype, try to stay kind of concrete and hopefully leave you with something that you can use when you get home to your own organizations. My name is Øystein Moseng. I am verifiably human. I completed a CAPTCHA yesterday successfully on the third try. And I am Chief Product Officer with Highsoft, which means I spend most of my time in meetings. I am a software developer at heart, though, so we're going to look at some code later today, hopefully, if the demo gods are with us. If you're not familiar with Highsoft, we are the people behind HighCharts, which is a suite of data visualization tools primarily geared towards developers. Front-end, back-end, JavaScript, TypeScript, whether it's vanilla or framework, React, Angular, Vue, Svelte. But then in later years, we've also expanded into Python, .NET, Android, iOS, native development as well. And what we're trying to do is kind of save developers a bit of time. So we'll get you up and running quickly if you want to do visualization, and then we'll sort of get out of your way if you want to get more custom and try not to work against you if you wanted to take it yet another notch. In the later years, we've been working quite heavily with innovation as well, and that's kind of what we're here to talk about today. We're looking at what's the developer going to be like in the future and how can we potentially help them out. So AI is obviously a big part of that. Now, I wanted to start with actually a real-life example from our internal Slack, if you can believe it. And this is a news article from NRK, which is the government media. It doesn't really matter if you can read it or not. It's a political piece. And I think it really shows the power of AI if you've sort of been sleeping lately and you don't really you're not really up to date of what's happening. So right here there's a blue box with kind of a summary that's OpenAI powered, and that helps the journalist write a bit of a summary of the piece, and then the journalist will quality assure that, which is nice. And here's a sentence, and don't worry, there's nothing weird about it. It just says that the county politicians in Vestland want to build bridges. They want to prioritize bridges over ferries because despite the county having the worst roads and the most landslide-prone roads in the country. Now, if you don't read Nynorsk, which this is written in, one of the two writing languages, you might turn to AI for a bit of translation, which also is quite impressive. So this is what Google Translate gave us. And I think, if you can't read that, it says that the county politicians want to build bridges to replace ferries despite us having the worst and most racist vegans in the country, which I don't think we do, but I appreciate it. And it's funny, which is part of why I brought it in, but it's also kind of relevant to the rest of the presentation because I want to talk a bit about how do we leverage AI for the strengths and not so much the weaknesses. And in this case, I think it highlights how AI can also spectacularly fail us, and quite unpredictably so. Okay, I want to talk about Dataviz. And I'm going to say something that sounds controversial, but I don't think it is. Data doesn't matter, and I'll follow it up with visualization doesn't matter, but I'll save it with insights matter. And the point here is that you can have all the data in the world, but most of the time we're trying to get something out of it. And so if you spent a lot of time on your visualization but nobody understands it, for example, you're kind of back to square one. And there might be a few exceptions here if we think of like data as art, for example, or just to drive engagement, just to be decorative. But most of the time we want it to be useful. And then I wanted to kind of take you on a bit of a trip through how we think about Dataviz and kind of where AI fits in, and then try to get into some code as well. So if we're building Dataviz, we tend to think of it as sort of a three-step process in a sense, because usually different people are involved. we're talking about the data gathering stage, or kind of the insights discovery stage, which is where you're trying to discover what your message is with the data visualization, so you're not sure just yet exactly what you're communicating. And then you need to decide how to communicate it. You know exactly what the message is, or at least what kind of discovery you want to facilitate for the end user. There's a design phase. How do you accurately represent this as a data visualization? And then someone has to build it, make it interactive probably. You don't just do a screenshot from Excel these days. And then finally there's a consumer that has to go through this and learn something from it, hopefully. And I think AI has a strong presence in the future in all of these three, and we're going to start with the data gathering, which is perhaps the most boring one. Usually, this is where you sort of massage the data, you kind of work on how do we efficiently store it, how do we work on the different formats and so on. AI has been used traditionally in data gathering for years when it comes to sort of dealing with data sensor data and that sort of thing. You can imagine image recognition, for example, on traffic cameras. But we're also seeing, actually, these days, companies using LLMs to automatically translate between data formats, automatically create adapters, that sort of thing. We do want to be a little bit careful there, not to just use LLMs for everything. A lot of that can be done deterministically. But that's one use case. But the use case that I think is really interesting here is when we talk about unstructured data. So if you think about the amount of information that we have in the world, a lot of it is human-to-human communication. A lot of it is asynchronous, and that's usually natural language. So if you think about just that pool of information, and there's an example of, for example, medical records, beautifully AI-generated doctor here. And in this case, the medical professional would have text notes in the medical records to communicate with other humans, other medical professionals, how to work with particular patients. And what we can do now with LLMs is make sense of that unstructured information, turn it into something that we can reason about, something that we can analyze, and that basically opens up a whole new pool of data information that we could otherwise not access, which is exciting, but also brings us back to the who cares question unless you have insights, which is the second part of this. And LLMs really here also play a role, and we've been experimenting quite a lot with this, and I'm going to show you some examples of that. But one of the things that we find it useful for is if you have really large data sets, it can be kind of hard to pick out exactly where you should focus your attention. So this is where we can see some AI co-piloting essentially happening in the analysis stage. And it's also lowering the bar, so you don't need to be a data analyst to do a lot of analysis these days, which is another effect of these LLMs. Another thing we see is anomaly detection. Obviously, that's been going on for years. But you can also see that in textual data these days, which is interesting because these models are context aware, and so they'll be able to detect anomalies beyond what you can do with just statistics. I'm going to show you something that we're working on, and I should preface it by saying that it's not a product. It's coming out of our innovation lab, which is kind of a dark, secret place in our organization with some brilliant engineers and other people working on kind of moonshot innovation and things that we're not sure if it's going to be viable from a business standpoint. Hasn't made it into product yet. And what I wanted to talk about is something they're working on called the High Charts Editor, which is really a tool for non-developers. And so the workflow is kind of similar, and I've got a video here. It's kind of similar to what we talked about, where you would bring in some kind of data and you would reason about it, you would do analysis on it, and that would sort of bring you to some sort of insight. The tool can also give you some automatic insights, suggestions from LLMs. And then from there, you're going to build out this visualization, again, using a conversational interface primarily, but there's also an option here to use traditional UI controls. And this is thought to be kind of an end-to-end tool and something that you could integrate into your workflow in your organization. So the data input and the data output stages would be typically adapted, and the theming and so on. So it's sort of a tool for the developers who want to make tools for non-developers. And what we're seeing here is that we're doing data processing through a conversational interface, which is one of the things we're going to show. And then here is the insights part, where it's suggesting some things in a data set that could be interesting to look at from an analysis standpoint. So yeah, we're excited to see where this heads. Let's see if we can move this on to the next one. But the interesting part really is on the insight stage here for me. How can we really use these LLMs to make the right decisions on what's insightful? And as we've been working on this, we've found some pretty critical problems that we need to solve. And I think maybe this is where we're getting actionable and we're getting concrete here. So I appreciate you bearing with me until this point. But the number one obvious thing is accuracy, I think. So data accuracy and data consistency is not something that we can compromise on. We have a lot of customers that are in a place where they have accuracy critical applications. And if you're working on data processing, you're working on data visualization, you can't really swap the numbers between March and February and get away with it. Or you can't really have your percentages be off by a point or two. This is something that we need to solve. The other thing is performance. I think that goes without saying too. These models are getting quite performant. They're quite impressive, but they're still a lot slower than typically solving problems deterministically would be, and that's an impact on the user that sometimes we can't compromise on. You can also think of this from the green code standpoint. It's very easy, I think, for us as developers to sort of see this new shiny tool and want to solve everything with it. But it's quite energy inefficient working with these LLMs, and so we don't really want to use them for anything that we don't have to. And if you're using a third-party service, then the cost starts to become an issue here as well. You don't want to send too much data to a third-party service because you end up incurring a lot of costs. You can imagine a user with a huge data set, and if we don't control that in any way, then we're going to pay for it, literally. Privacy is the final one, and probably an obvious one, again with third-party services. Enterprise customers don't really want to send their data off to OpenAI unless they have a partnership with them. And in the EU, obviously, there is GDPR and everything to consider. So this needs to be handled as well. And I think we've got some tips, at least from our perspective, on how to deal with these. And the first one is kind of way too obvious to talk long about, but I'll mention it. We want to use the LLMs for what the LLMs are good at and not for what other things are good at. So, for example, you don't want it to do math. You can ask ChatGPT to do math, and sometimes it'll do it okay. But generally, this is not the tool for the job. And OpenAI knows that. And so they've put in processing capabilities where they're going to be running code in the background to do processing instead, which we think is a better way of handling it. And one way to do that is to give LLMs instructions instead, to give you a recipe of what to do. So instead of the LLM doing the data processing, the LLM's job is just to do the natural language processing and turn that query into basically a stack of actions that you're going to do deterministically, which could look something like this. So you might have a query that asks you to show inflation rates for Greece by dates from 2022. You might have some metadata or even your entire data set, and you're sending this over to the LLM, and you're getting back essentially then a stack of actions. So in this case, you might be filtering dates that are greater than or equal to 2022. You might be sorting by the date column, and so on. And what we've found works pretty well, actually, is not sending the data set at all, but sending metadata about the data, and that's actually enough to do quite a lot with this kind of approach. So we can send over the names of the columns, we can send over the types of the columns. If it's numeric, we'll typically send over minimum, maximum, average, some statistics. If it's a string type column, if it's text, we found it's quite useful to send over a sample of some unique strings, perhaps like the 10 first unique strings, and that will give then the LLM a better chance at interpreting the format of the data. So by doing that, essentially what we're doing is we're minimizing the complexity, and we're solving kind of the accuracy problem to a certain extent anyway. Of course, the stack of actions could be wrong, or the parameters could be wrong, but at least we've reduced the complexity significantly to where the hallucinations are much more palatable. But we've also greatly reduced the amount of data that's going out. And so actually what we end up doing here now is just sending a very, very small amount of data, even for huge data sets, which also solves the cost problem, and to a certain extent it helps us solve the privacy problem. Now, if we're sending over string data and column names, that's already problematic in some cases, but at least we're a step closer. There is a nice new kind of field, I should say, that's prompt engineering. And so we made kind of a few observations of what works for us there. This is going to be fresh information, obviously. It's model dependent, it's going to change. But definitely what's worked best for us with this type of work is keeping things short, keeping the prompts concise and unambiguous, which sounds good in theory, but then you have to actually do it in practice. And essentially what we end up doing is we're trying to stick with one-shot API calls, trying not to use the context that some of these models and APIs will allow for. We're trying to handle the context ourselves as much as possible. We also try to route different queries to different, more specialized models. And that could be specialized in terms of prompting, could be specialized in terms of context, could be specialized in terms of training or configuration, but what matters is that we're able to kind of narrow down or restrain the models to be less ambiguous. So that might look something like this, where we have some user input. On the left side, we're passing it through a router, and this could be a deterministic router. We've also used LLMs for this. And the only job of that is to figure out what kind of query is this, where does it belong? And we'll pass that through to wherever it belongs. So top one here would be, what's the best chart type for this given data, for example? Or could you translate this input to high charts configuration? I mean, those are two very, very different tasks. Or finally, like we looked at, can you transform this input to a set of actions to be performed on a data set? And this works quite well. And then another thing that we find works quite well is giving some examples. So example input, example output. This is actually the #1 prompt engineering tip from our AI engineers. So if you have just a few examples, it really does narrow down where these models tend to drift. I think it's coding time. I don't usually do live demos, and there may be really good sort of reasons for that. So let's see if that works. My tiling window manager is fighting with me. I'm going to do this in JavaScript, Node, and it doesn't really matter if you're a JavaScript person. I think it's quite straightforward, and what really matters here is it's the concepts. And what we've got here is basically just a static data set, and we're going to play around with a little bit here with the routing and also this data processing. So I got the static data set, and if I run this, all I'm going to get is just a prompt, and I can ask it questions. And in this case, I've decided, we're going to have 3 kind of agents that will work with this input, depending on what the query is. One is going to deal with data processing. One is going to deal with data visualization and sort of the high chart side of things. And then one is going to take everything else. So if I just ask, why are sheep green? This is going to return with, let's use the other agent, so the everything else. And then it very helpfully tells me that sheep are not naturally green in color, which is good. There could be a rare occurrence of a sheep being dyed. That's very, very good for entertainment purposes. So let's try this. If I do show me the data right now, this should be a data processing query. And it is. And this actually now happens deterministically, so I can trust that this data is correct, and we'll talk about that in a second. But this is now exactly the data that I've put into the code. And I can ask it to do something like, show me Tokyo temperatures only, sorted by date descending. And thankfully, that was considered to be data processing, and that got me back now Tokyo temperatures only, and it is sorted descending by date successfully. And hopefully, if nothing's horribly wrong, all the numbers are correct. So if you look at the 1st of January 22 here, that's 6.52, that's right, 624 is right, 1089 is right. So this is deterministically handled. Now if I wanted to, show this as a line chart, hopefully this will be the height charts expert agent handling this. So that's the router successfully routing. And this is taking a little bit longer, and part of the reason is we're sending over the entire data set in this case, just because I was lazy. But it returns now what is a height charts configuration as JavaScript. And just to be brave, I'm going to try it. So I've got just an HTML boilerplate here, very minimal. And we're loading height charts. And if I paste that in, that's rendering it to a container div, which we've defined here. And I think if I bring that up, that's a chart. So that's worked quite well. And I promise I'm not cheating. That is the actual index.html. But the interesting part here really is in the routing, and how do we deal with that, and then in the data processing. So let's take a little moment here and get coding. We're using the OpenAI API here, which is really easy if you're a Node developer or Python developer. So comes highly recommended. Otherwise, I've set a global temperature constant here just to play around with it, and set it fairly low just to get a little bit of stability out of this, because I don't trust the demo gods. And then we've got some functions here that we'll talk about in a second. So basically, the only thing that's happening here is we've got a function to figure out which agent do we use. We're just finding these agents. So if you're data processing, this is what we're doing. If we're visualizing, this is what we're doing. If it's something else like green sheep, this is what we're doing. And then we're just continuously reading in some user input here. And this is the result of the user input, which we're then passing to which agent are we grabbing. We're just doing a switch on this to be super explicit on what's happening. Normally, you might key this into a dictionary and it'll be a little bit more elegant, but I think it's quite clear here what's going on. If it's the data processing agent, and we're calling that. If it's the height charts expert, we're calling that. Otherwise, it's this one. And just a minimum of error handling, just so you won't yell at me. There's a default case. So these agents are receiving the query here from the user. They're also receiving this, what we call the data session, which is the current state of the data. Because I don't know if you noticed, but when we asked the height charts expert here, we said show this as a line chart. And we're not doing any context with the LLMs here. We're using potentially different models for different things. So we have to tell the height charts expert what this is, basically, and pass in the data in this case. So that's all that is. And then the data processing agent might make some changes here to the data. So I think the easiest one to start with is actually the other agent, because it's dead simple. This is just the completions API from OpenAI, and if you haven't used it, it is very simple, so you should probably try it out. Quite powerful. And all it is a system message that says it's helpful, and it's focused on data processing and visualization, and that's all we really need to tell it. Just using 3.5 Turbo here, because we don't really need this to be super intelligent. That's fine. And then we're just logging whatever the result is, and we're not even doing any error handling here, so you're allowed to yell at me if you want to. The height charts expert is similar, slightly more complex, just because it has a longer prompt, and we're actually not using the system message here. So this is something that we've experimented our way into, and with OpenAI at least, this tends to work better, where you just basically inject the user input directly into what would be kind of like a system message. And here you can see how we're giving input and output examples, just to give the LLM kind of a direction to go in here. You will notice that we're passing in the entire data, and this would be then the data session, so the localized data, which is terribly inefficient and not what we would do in production. We'd want to do something more like with the data processing, where we're sending in just metadata and sort of parts of the data. And also this prompt, we didn't really work on making that useful, but it did work with my example, so I'm happy. I should mention that we're working on kind of our own HighCharts GPT, and if you're a HighCharts customer, you might have seen that. So that will give you better results for exactly this type of thing, where we're able to kind of go in with embeddings and fine-tuning and things like that, where we can actually give you better results than what something like OpenAI out of the box can. But this works for the purposes of showing the router. Let's show the router, because the data processing is a little more complex. The big difference here is in the tools. So I'm going to talk about that in a second. But basically, we have a prompt here that says, there is a message being sent. You've got some very limited choices, and those would be, is this data processing? Is it HighCharts? Is it something else? And then you're instructed to, call whatever appropriate function to route this message to the correct agent. And some of the terminology here is, just not very tried and tested, but let's, for the purposes of this demo, assume that this was a well-engineered prompt. And what we're using here is OpenAI's way of defining sort of data processing or any kind of deterministic behavior that you want to control, but you want the LLM to help you decide when to do it and how to do it. So you could do this just by saying, here's my grammar for how to give me a list of actions. Give me a stack, maybe it's JSON, maybe it's something else, and sort of define how you want the LLM to return that, and then you will parse it manually. But since we're using OpenAI here, they have what they call function calling, and you define that through tools. And tools in this case is pretty straightforward. It's basically just a JSON schema definition of a function. So you're going to say that, well, this tool is a function, and that's the only type they support at the moment, I believe. So not too exciting, but it's a function. It has a name, which is what the LLM will tell you it wants to call if it decides to call this function. It has a description, and then it has some parameters. And the parameters also will have types, and they will have description. And in this case, it also has enum, which would be then valid types, valid values for this type. So we're able to limit quite severely now the response of the LLM, at least in theory, because the models will have been fine-tuned and trained on this type of format to know what to return. So one thing to mention is that hallucinations are still very much possible. So you could get function calls that are not defined, or you could get properties that are not defined, values that are invalid, and so on. So a little bit of error handling wouldn't hurt. But it seems to be quite stable, at least for cases where the query matches the description quite well. And so this is obviously where sort of the mini prompt engineering comes into play, where you need to describe these properties, these parameters, and the functions quite well and quite concisely in order to kind of guide the LLM to the right actions. We're passing in which routes are allowed here, so that's just our enum, and that means when this comes back, the LLM will have said, I want to make a tool call. In this case, we've said that you got to make a tool call, so you better make a good one. And we're not doing any error handling again because it's just a demo. But if I were to beautifully log, let's just grab the tool call specifically. I'm going to give it a semicolon just for show. And let's run that again. If I now ask why are sheep not green, this should now pass through the router, and the router will make this tool call to figure out which one. and this is what we're getting back. So the tool call just looks like there's an ID, and sheep do not contain chlorophyll. That's good. Okay. And then there is a function here, and so it's got a name, and so this will be then your key probably into a dictionary, right, of the functions that you've decided to work with. And then the arguments, this is just a stringified JSON, so you need to parse that. But that's quite flexible then. Let's remove that. And so you can see here we're just parsing the argument specifically and grabbing the agent out of that. And every time we're going to just call the one function because it's the only one we've got. If we look at the data processing, it gets a little bit more complex. Actually, the definition here is simpler. There is no required tools. It allows the LLM to just decide, do you want to call a function or not? And then the message is just passed straight through. I didn't even bother making a system message for this. And then let's look at the response. Well, if there is some content in it, we actually want to log that here. We haven't required it to make any sort of function call. So if I here do what is 2 plus 2, it's probably going to think that's data processing. It does, yeah, and that's just going to, do it in the LLM basically. So that's logged. But then if there are tool calls, there could be multiple. And I think we saw that when we grabbed Tokyo only and then sorted it. That would be 2 tool calls here, and so we're grabbing a copy of the data just to be functionally sound. And we can choose between 2 functions that we have defined here. Either we set which columns are visible, or we're sorting by a specific column. And those are defined very similarly with a name, some parameters, and you can see here that columns would be an array, and it has only some allowed values here, and those would be the column names of the data set, which we're grabbing here from the data which we're passing in. And then if you're sorting by columns, you can have up to 2 parameters in this case, one being which column, again, limited to just the column names, or whether it's ascending or descending. That's not a required parameter, but which column is required. And then what's going to happen here is, well, we're going to just call these functions. And again, you would probably key this into a dictionary or something, right? But in this case, just very clear what we're doing here. We're passing in the data, we're passing in this argument from the LLM response, and we're making those changes to the data, which are then returned from the agent. And just to briefly take a look, these are just standard functions to deal with just this specific type of data format, right, with a 2-dimensional array, so not very clever, but setting the columns then visibly and sorting them by the columns, and being smart enough to deal with dates, just because I tried without first, and that wasn't much of a demo. So that would be the code, and I think it kind of shows a little bit of how you might go about starting thinking about this, and you would probably engineer this a little bit differently if you had a lot of actions. You would, consider the JSON schema to be probably closer to the function definitions to avoid all of this back and forth. But overall, it's quite easy to work with this with the OpenAI API, and then if you wanted to, you could obviously make your own grammar, however you wanted to do that, and then parse the output from the LLM to work on things your own way. Okay, let's switch it back to slideshow mode. So far, we've talked pretty much just about like data gathering, data processing, insights, and really a pretty big part of what we're doing day to day as software engineers, we're building stuff. And I think if there's one place where we've seen the impact of LLMs so far, it's in building stuff, code generation, certainly co-piloting, that sort of thing. So I already mentioned the high charts GPT way that we're going, the sort of direction we're going with, sort of trying to give you this high charts expert that you can ask 24/7, and it will give you better output than what OpenAI can do. And I believe we have a video of that here, so let me just quickly show that. This is likely to also be an API in the future, but right now it's more like a chatbot. And the idea, obviously, is that we're able to kind of also show charts directly on the page, and we're also able to give you links to copy the code and so on and edit it directly. So that can be useful. But as a builder, there's another part of Dataviz that can be quite tricky, which is how do you know what a good data representation really is? If you're not a Dataviz geek, do you know if you have categorical data or continuous data? If it's categorical, is it ordinal? Is it nominal? All these terms. And then, what's your objective here? Are you trying to do comparison? Are you trying to show flow, distribution? Compositions? And so we pretty early actually started looking into how can we guide people into making these decisions from kind of a design standpoint. So this is a screenshot from our chart chooser, which is just a free tool. So you might want to look at that and sort of go through it manually, but we're also seeing, like in the editor product, how this could potentially be part of an end-to-end solution where the tools will be able to give you kind of design hints as you're going along, and potentially also validation, right? So you can see that, okay, maybe this was not the best use case for 3 y-axes at the same time. Maybe this makes it a little bit tricky to read. Let's see if I can skip that. Yeah. And then the final thing I wanted to talk about actually is on the consumption side of things. Because if we're building and we're able to build good data visualizations, someone still has to draw insights from it. And that can also be remarkably difficult. And I'm not sure how many of you are familiar with accessibility for people with disabilities, like digital accessibility. Raise of hands. Yeah, quite a few, but not everyone. And this is a field where we've spent quite a lot of energy trying to work on how would you make a chart accessible to someone who's blind, for example. And you might think that's absolutely impossible, but it's really quite doable, but it's difficult. So one of the things we're doing is, for example, audio charts, where you would be able to represent the data using sounds. And that's one way to tackle it. But another way that's quite interesting now with LLMs is you could have a conversation with a chart, and you could ask it questions, and you could ask it, the things that you are wondering about the data. And in reality, then you're kind of working more directly with the data and less so with the representation of it. But this is definitely an area where the LLM tools are starting to show some promise. I think I'm going to just wrap it up and say, we've got some takeaways here. We want to make sure we use this for what it's good at. So using the LLMs not for data processing, but using them for things like natural language processing, sort of making structure out of something unstructured. We're very happy to pair it with traditional approaches. So we're seeing that this doesn't have to be sort of a binary thing where it's all AI or it's all deterministic. We get faster results actually these days with a hybrid approach. And then this is a typical kind of conference sentence, isn't it? The future is exciting, but I think it resonates with me at this point because we're builders, we're software engineers. It's kind of up to us to take this exciting new technology and make something out of it. And I think it's up to us really to define where we want that future to be. So to me, at least, that is exciting and therefore worth a conference sentence at a conference. All right, that's it for me. Happy weekend, and I'm glad you made it this far in the conference. I do have some contact info here. Happy to chat, in the hallways or elsewhere if you want to talk about tech. I also have some merch in my backpack, so if you want some trendy Dataviz socks, come see me. But yeah, that's it for me. Happy weekend.